The sun generates an enormous amount of heat through a process called nuclear fusion. Let's explore this in detail. The sun's core. The sun has a central region called the core, which is the hottest part of the sun. The core is incredibly dense and has extremely high temperatures, reaching around 15 million degrees Celsius, 27 million degrees Fahrenheit. Nuclear fusion. Inside the core, a process called nuclear fusion takes place. Fusion occurs when atoms join together to form a heavier atom, releasing a tremendous amount of energy in the process. In the case of the sun, the fusion process involves hydrogen atoms coming together to form helium. Proton-proton chain. The most common fusion process in the sun is called the proton-proton chain. In this chain, four hydrogen nuclei, protons, combine in a series of steps to form one helium nucleus. During this process, some mass is converted into energy according to Albert Einstein's famous equation, E=mc². Energy release. As the hydrogen nuclei combine, a small fraction of their mass is converted into energy. This energy is released in the form of high-energy photons, which we perceive as light and heat. These photons travel from the sun's core to its surface, eventually reaching Earth. Solar radiation. The energy released in the sun's core takes a long journey through the sun's layers before it reaches the surface. It first passes through the radiative zone, where it interacts with atoms and is gradually absorbed and re-emitted as it makes its way outwards. Photosphere and sunlight. The surface of the sun, known as the photosphere, is the visible part that emits sunlight. The photons produced in the core escape from the photosphere, creating the sun's intense brightness and heat. The photosphere has a temperature of around 5,500 degrees Celsius, 9,932 degrees Fahrenheit. Sunspots and solar flares. The sun's surface exhibits regions called sunspots, which are cooler and darker areas caused by intense magnetic activity. However, even in these areas, the temperatures are still incredibly high compared to anything on Earth. Solar flares, which are powerful eruptions of energy, can occur in regions of intense magnetic activity on the sun's surface. Solar wind. Apart from heat and light, the sun also emits a stream of charged particles called the solar wind. These particles, mainly electrons and protons, are continuously released from the sun's outer atmosphere into space. The solar wind interacts with Earth's magnetic field and can cause phenomena such as the northern lights, aurora borealis. In summary, the sun produces an immense amount of heat through the process of nuclear fusion. The hydrogen atoms in the sun's core combine to form helium, releasing energy in the form of light and heat. This energy travels from the core to the sun's surface, where it is emitted as sunlight. The sun's intense heat powers our planet and sustains life on Earth.